So I want to give another lightning talk about the VoltDB architecture, how VoltDB works, and how we interact with it, and how it's going to be deployed in our environment. So the plan is that we would have 2 VoltDB clusters, and a VoltDB cluster at minimum is 3 servers. We may actually have 5, if they recommend 3 to 5 servers. So we'll have 1 cluster east, one cluster in the west. VoltDB does cluster-to-cluster replication, so that will be managed by VoltDB. Now, we will be running our west and east regions in AWS for Platform 28. So from a customer's perspective, they are talking to customer platform 28. The customer is talking to either east or west. They don't care. We will run our app servers over here on both sides in an active mode. How does this work? Well, we're going to use east as our primary database site. So all of the west will be pointing here, and so will the east. In case there is a failure of the east site, something happens to this database, we will automatically switch this stuff to point to here. So this is our backup path. So as long as the east is running, everybody's pointing here. East goes down, we switch over and point here. The reason we're doing this, at this point, VoltDB hasn't, in my opinion, fully proved to us that they can run active-active. They have released the active-active functionality, or they have the active-active functionality, but we would want to kind of wait it out, make sure that we're not the guinea pigs that we try this out on. But the active standby, on the other hand, they are using it in production today, and it works great. Because VoltDB is able to handle this, our latency here, the last time we measured it, was somewhere between 90 to 100 milliseconds. To VoltDB, this is fine from a latency perspective. From our perspective, from an application perspective, any transaction is completed once it has written to the primary site. So we will not wait this 100 milliseconds over here. We're actually going to get much higher throughput because as long as it's written to the one cluster, we're going to consider it complete. These guys, on the other hand, are going to incur a 100 millisecond delay. So every transaction from here is going to have this overhead of 100 milliseconds. Now, realistically, will that impact us? We've done systems like this before where it goes from California to New York. We've not had any issues. No, there's no perceptible issue for the end user. There is a slight delay. And what happens is it doesn't actually build up a queue of transactions. All it does is every transaction is delayed. So if this is a time series, the request is here, the response is here, the next request is here, the next response is here, the next request is here, the next response is here, so on. So the delay between each one of these is pretty much fixed. So customers don't really feel that as a delay when they're using the system, but that is something that we need to keep in mind as we design parts of the software. Now VoltDB is a little bit different than MySQL in that it has to keep everything in memory. So the data that we're generating, CDRs, audit trails, all of that data cannot reside in VoltDB because at some point, the amount of data that we have will overwhelm the system, which means we need to add more very expensive servers with a lot of RAM, or we save this out to somewhere else. Now that somewhere else, for reporting purposes, and for right now, we can send it to an RDS instance or a SQL-based server, just because VoltDB has a built-in functionality so that kind of over here, anything that comes into the database can also be cloned and copied to another source. So all the data that we're inserting, all the stored procedures that we're calling, the data they're inserting, any insert to a table also gets sent out to the SQL. The cool thing about this is our reporting layers can pull data from here if you want 3 months of data. But if somebody wants a report of the last day of data, the reporting layer can pull the data directly from VaultDB. This might be 30 days, 90 days, 120 days, but we can't keep this data forever. Well, that's where Hadoop comes in. So the next step is this data is serialized into Hadoop. Now Hadoop, I don't know how familiar you are with Hadoop. Hadoop is really, really, really meant for long-term data storage. Not, it's not really good at instantaneous transactions. But if somebody wants to run a report for 12 months or 36 months of data, this is the perfect data source for it. When we get to this stage, we will have to do some serious rewriting because, while Hadoop is great for long-term data storage, it's not good for querying the data. You can't use SQL. Now, Apache has some layers now that will allow you to use a SQL query against Hadoop, but the traditional and the best way to query Hadoop is to do a MapReduce. So this is something that's on my roadmap that the database team has pretty much, once we start Hadoop, we have to start MapReduce for all the reporting that we're doing. But the MapReduce is really cool because the way it works is it goes out and says, I want a report of ASA for the past 5 years. No problem. We split this up into jobs, and each one of these jobs gets distributed to all these little tiny servers, and each server is only looking at a tiny fragment of the data within Hadoop. Then the reduce algorithm collects that and gives you the final output. Okay, so hence MapReduce. You map the data, then you reduce it, gives you the final output. So again, going from real-time data in VaultDB to near-term storage in SQL to long-term storage in Hadoop. So these are pretty much all of the database technologies that we're going to be using. Now, VaultDB, one of the issues today that we have is there are certain parts of the system, specifically the resource manager within the ACD. So we call it the ACD, it's no longer an ACD, it's really a resource manager. But the resource manager piece is very critical because, again, as I said in another lightning talk, you cannot have the same resource being assigned to multiple activities. Unless, of course, they are a resource that can be shared and the activity itself doesn't take 100% of their time. So what do you do instead? Well, remember, resources are specific to organizations. Okay? So as long as you're not crossing organizational boundaries, you could, in theory, run multiple ACDs. The way we're partitioning VaultDB is each organization gets a partition. Now that doesn't mean we're going to run 3,000 servers. What it really means is maybe if there's 3 servers, for sake of argument, 1/3 of the organizations will be here, 1/3 will be here, 1/3 will be here. And it'll use a hash function to determine that. We don't do it, VaultDB does it, their API does it. So that when a request is made, it'll go to the correct server and a response comes back. But what this means is now things like the ACD, which currently have to be tightly controlled, can actually also become horizontally scalable. So essentially every organization has its own ACD. Now, will we do that again on this layer? Probably not. But if we have 3 VaultDB servers, we can now have 3 ACD servers. That way the load is split up between the 3 VaultDB servers. The ACDs actually respond faster, and also you don't have the issue of an ACD gets stuck or breaks and takes the system down. Because these 3 ACDs can all talk to each other, if something happens to one of these, the other 2 can say, okay, now I'm handling odd and even organizations. where this was 33, 33, 33, it'll split up 50-50. So that's also something that's on the roadmap, and that has to happen in conjunction with phase 2 of the VoltDB implementation. That is when we actually move the database to the VoltDB. That's it. Thank you.